All right, this is our last section in factoring. It's solving quadratic equations by factoring. And the difference between this factoring section and the ones we had before is we actually have an equation. Okay, and remember an equation has an equal sign in it. So the steps for solving these problems is you always want to make sure you have the equal zero. And if you don't have an equal zero, if you have equals a number or something, you have to get the equal zero on one side by itself before you can do your factoring. Once you have that equal zero, then you can factor your polynomial using your methods that we've seen before. You have your GCF, you have your factor by grouping, you have your bottoms up, and your difference of two squares. And then you want to set your factors equal to zero, solve the equation, and that'll be it. Now, before I go any further, I do want to remind you of all the different factoring methods. I just listed them out loud, but I want to write them down so you can actually see them. So the factoring methods that we started with, the first one was our GCF, our greatest common factor. Then we did grouping, and remember when we did factor by grouping, we factored out a GCF for the first two terms, and we brought down a sign and factored the GCF for the last two terms. You can only do grouping when you have 4 terms in your polynomial. Then we talked about bottoms up. And when we did bottoms up, remember this was of the form ax squared plus bx plus c. This is when you had 3 terms in your polynomial. Okay? And we also had GCF and bottoms up sometimes, but bottoms up was 3 terms only. You can only do it with a trinomial. Then we talked about the difference of two squares. And the difference of two squares actually gives away how many terms in the actual, the title of its name. So you can only do difference of two terms when you have 2 terms, a binomial. And remember, it has to be the square root of the first and the last, and you have to have a minus in it. And then the last one we talked about was the perfect square trinomial. And again, this gives away the answer. It has 3 terms in these problems, and you can take the square root of the first and the last. And it was a quick shortcut method for factoring trinomials that were perfect squares in the front and the back. Okay, so these are your different types of factoring methods. You're going to need to be able to recall these. So write these down. And for the GCF, the reason why it doesn't have a term beside it, an amount of terms, is because it doesn't matter if there's 2 terms, 3 terms, 4 terms, 5 terms. As long as you have a common factor to all the groups, then you can do the GCF. So the GCF could actually be worked with any amount of terms. The other ones are very specific. So you always want to look for a GCF first, and then you can narrow down what type of factoring method you're going to use according to the amount of terms you have on those particular problems. So let's go ahead and start with our first example. And remember, you're always trying to get the equal zero by itself first. So that's the first thing you want to look for. Do I have an equal zero? I do. So after you look and see if you have an equal zero, look how many terms are left. I have 1, 2, 3 terms. So that means a trinomial. And if I have a trinomial, I'm either going to do bottoms up or a perfect square trinomial. And this is definitely not a perfect square trinomial because I cannot take the square root of 20. So I am going to have to do the bottoms up with it. So I'm going to multiply the first and the last. And I want to find the factors of 20, 1 times 20, that add to give me a negative 9. I'm adding to get a negative 9. Okay, so the factors of 20, I have 1 and 20, 2 and 10, 4 and 5, and if I add 1 and 20, I get 21. If I add 2 and 10, I get 12. But if I add 4 and 5, I can get 9. Okay? Now remember, when you're adding, you want the same sign, and you want them both to be the sign of that middle term. So they're both going to be negative. And so notice that your steps I have gotten my equal 0. I've factored my polynomial. Now I'm going to do my bottoms up. So I'm going to divide by my x, my leading term. So when I do my bottoms up, I have x minus 4 and x minus 5. We are not done here. Bring down your equal 0. This is where we set the factors equal to 0 and solve the equation. So the factors, this is a factor and this is a factor. So I have x minus 4 equals 0 and x minus 5 equals 0. So our first factor is the x minus 4, and to solve the equation, I just get the x by itself. So I'm going to add 4 to both sides, and x equals 4. For the second equation, I'm going to add 5 to both sides, and x equals 5. Now, on Course Compass, how you're going to write this in your answer box is you'll just put 4, 5, and that's going to be your answer. Okay, you don't put x equals 4, you just put 4 and 5, and that's it. Okay, so always want to make sure your equal 0 is first. Then you decide what type of factoring method you can use, determining on the factor or the number of terms in your polynomial. And then once you factor it, you set your factors equal to 0 and you solve your little equations, and that's going to be your answer. We'll pick up on the next one in the next video.